They do love him. They do love him. All right. This is actually probably one of my favorite things to do. I know it seems weird. Implicit differentiation, after you take Calc 3, you have to take something called differential equations. And this is like all inside of differential equations. It's really kind of fun. But let me just explain real quick what implicit differentiation is and why we use it. Implicit differentiation. Remember, differentiation is just the process of taking a derivative, okay? So what happens is we could get really, really crazy complicated equations that are too difficult to take a derivative for. So when the equation is too difficult to express, to express y as a function of x. Meaning, if you can't solve for y easily, you have to then do implicit differentiation. And it's actually very easy. It's much easier. You could do this with all the derivatives that we've already been doing. You can do implicit differentiation. But you really definitely want to do it when you get what looks like a very complicated x's and y's and y squared and y's cubed. You want to do implicit. Because how would you solve for y? I mean, you could get everything over to one side, but it still will be all messy looking. And I'll give you an example right now of what I'm talking about. So find dy dx, which means find the derivative. That's just, again, all about notation, understanding what this notation is of x cubed plus y cubed equal to 5. Now, again, couldn't we solve this for y? Yeah, we could. We could minus the x cubed over, take a cube root, and then do the derivative like we've been doing, right? Everything we've been doing has already had a y. It'll, even though it doesn't say y equals in front of it, it's already solved for y. But this one is a little bit more complicated. So I'm going to write a few little steps down here on the side. I want you to treat x treat y as a function of x. And I'll explain what that means in a minute. You are going to derive both sides with respect to x. Okay. Then the third thing you're going to do is every time you take a derivative of y, you need to attach dy dx. And I'll explain this as we go. I just want you to write this down. And then the fourth thing you do is solve for dy dx. Okay, so what we're doing is we're going to treat y as a function of x, which means we're going to derive both sides with respect to x. However, if we take a derivative of y, we have to attach what's called a dy dx. And then we solve for dy dx at the end. I know it seems weird, but not that hard. So here's what we're doing. So x cubed, ready? What's the derivative of x cubed? You should all know that. 3x squared. Did you take a derivative of a y?
No.
Then you're done for that one.
What?
Just for that one. No, just for that one. All right, now we're going to take the derivative of y cubed. What's the derivative of y cubed? Did you take the derivative of a y? Then you attach dy dx. If you take the derivative of a y, it's essentially attaching a chain. Take the derivative, attach dy dx. Equals, you have to take the derivative of this side also, which everybody forgets. What's the derivative of 5? 0. Okay, that right there, you have just taken an implicit differentiation. Now you solve for this, meaning you get the dy dx by itself. So what would you do?
Bring over 3x squared.
Minus 3x squared. So you have 3y squared dy dx equals negative 3x squared. Then what? Divide out the 3 and the y squared. Boom, boom. And what is our final answer?
Negative x squared squared over root of y squared.
Over y squared. Now, how is this different or the same from what we've been doing? So you remember when we would take the derivative or the slope, and what we would be left with are just x's, and we'd plug in an x, right? Now I have to find the what? I don't just need to know the x point, I also have to know the y point. I have to know both points. That's the only difference, really. You just took the slope. You instead, if they give you, all right, find the equation for the tangent line at x equals 1, well, then I also have to know what y is. That's all it is. There's your derivative. How hard was that? Don't worry, it gets more fun. Just you wait. You're not loving it. You're like, I don't know yet. I don't know if I love it or not. Let's get a little bit more complicated because we're smart children and we can do complicated things. Remember, it's not getting harder, you're getting smarter. See how lovely that one looks? Could you imagine solving that one for y? How are you going to solve that one for y? It's sine
You
y.
have to do the weird thing.
Okay, so we're going to not solve for y. We're going to do an implicit differentiation. We're going to take the derivative of every little thing I see. This guy, this guy, this guy, this guy, okay? Take the derivative. If I take a derivative of a y, I attach dy dx. Get that in your mind, okay? If I take the derivative of y, attach dy dx. All right, x cubed sine y, oh, what's that? Okay, we can do that. We got this, product rule. First, times, what's the derivative of sine y? You remember what it is?
So it's cos y?
Cosine y.
Yes.
But wait a second, did you just take the derivative of something with a y?
Yes.
So what do we have to attach? Every time you do it with y, you have to attach dy dx. Okay, so first times the derivative of the second times dy dx plus,
One,
what would be the second?
Sine y.
Did you take the derivative though?
No.
Okay. Times derivative of the first, what's that? Do I have to attach dy dx or anything?
no.
Done. Does that make sense to you? Okay, that is only this.
Fine.
Okay, so now that we've done that one, let's do this one. What's the derivative of a y? What's the derivative of just an x? What's the derivative? 1, but we took the derivative of a y,
This is just dy dx.
so I put plus, so it would be 1. If you want to write 1 dy dx, you can, just to understand. You took the derivative of y, which is 1, and you attach the dy dx. Equals, what's the derivative of 4x? 4, don't need to attach a y, dy dx. What's the derivative of 3? Okay. So now, I'm just going to clean this up because I just do not like the way it's written. Well, I think you might be able to. Actually, I'm going to keep it a little bit like it is. I want to get all my dy's dx on this side. So do you see how this term has a dy dx and this term has a dy dx, but this guy doesn't? So I'm going to move this whole thing over. Do you all agree to that? Okay, so I'm going to keep x cubed cosine y times dy dx. And I'm going to keep this plus 1 dy dx. And again, you don't have to put the 1. I'm just putting it there. Equals 4 stays on this side. And then I like to put the 3x squared in front of the sign. That's just me. So I'm going to write minus 3x squared sine y. Did I lose anybody there? Did that make sense? I just brought that whole term over. And I just put the 3x squared in front because I don't like anything after sine of something. I always like that monomial in the front. All right, now, how do I solve for dy dx if both of these have a dy dx? Starts with an f and it ends with an actor.
Well,
Factor. Take out a dy dx from both of these little things, and what would you have left in this first position? X cubed cosine y, right?
What are we taking out?
We're taking out a dy dx from this term.
Oh, it's dy dx.
Okay. If I took out a dy dx from here, what would I be left with? See how that 1 kind of helped me out? Because if I didn't have that 1, some of you might have just thought it didn't exist. So equals 4 minus 3x squared sine y. And now how do you get dy dx by itself if you have this and you're multiplying by it? What do you just do? Just divide that whole thing out. This is very nasty looking. X cubed cosine y. Oh, I just wrote coy. Cosine y plus 1. And that is the derivative. So if they gave you an x and a y point, you would plug it in here to find the slope value. How do you feel? It's kind of different. I know it's weird.
A much bigger step than example 1.
Much bigger, yes. Well, we're about to get kind of, I'm going to do.
So tell me we're going to use and all that stuff.
Not really. Not really. I'm going to do one. Going to do one more, and then I'm going to actually do one of your homework problems, and then we're done here. Call this d squared. Mm-hmm. Anybody remember what that represents?
Oh, the second.
Second derivative. So,
Shoot, I hate these.
I know.
Why did you do these on these?
I'm sorry. All right, so I just did this for you, actually. Didn't I already take the derivative of this?
Yeah.
Go back to your example 1. Isn't it there already?
Negative.
Okay, so let's rewrite that down from, let's say from example 1, the dy dx was, oh, let me go back. Was it negative x squared over y squared, right? Okay, so that is the first derivative. Now we're going to take a second derivative because that's what it's asking for. Okay, so second derivative is a quotient rule. Exactly. Okay, so you have to do the quotient rule of this because this is a quotient. So we need to do a quotient rule. So the quotient rule says denominator, which would be y squared, didn't take a derivative though, times the derivative of the numerator, which is negative 2x, minus numerator, negative x squared, times the derivative of the denominator. What's the derivative of the denominator? 2y, 2y, 2y. Yay!
yeah.
Every time you take the derivative of y, you attach a dy dx. Okay? Over the denominator, what?
Square. Or y to the 4.
Okay, now, I hate the way this looks. I've got to clean it up. It looks too nasty for me, so we're going to clean it up real quick. So this is all being multiplied together, so I'm going to just call this negative 2xy squared, because I like to go in alphabetical order. I like my coefficient in front, and then I like to be in alphabetical order. So then how would you write this? What would the sign now be? Plus 2x squared y dy dx. Do you all agree? Because this is all multiplication, correct?
Yeah.
And then the bottom would be? Okay, now this is about to blow your mind because this always blew my mind. You have one problem like this, by the way, and I think that's the 311 that I'm going to be doing. What's this?
Y dx.
Yeah, but what is it?
Plug it in.
Yep. That's how you have to clean it up. We already have solved for dy dx. Didn't we already solve for dy dx? So I am allowed to plug that back in here because I already have a solution for it. So, and you have to clean this up as part of your lovely job. 2x squared y times negative x squared over y squared. All over y to the 4th. See, this is why you get good at algebra, y'all. That's why you get good at algebra. Now, can you clean this up anymore? Can you just clean up that portion for me at all? What would that final answer be there? Can't remember, this is over 1, right? So we can cross cancel some y's out. Would you agree? Okay. So I would have negative 2xy squared. A 2x squared times a negative x squared becomes what? Negative 2x to the 4th over y, all over y to the 4th. Anybody know how you can clean this up even further? I know you're like, really? We're not done yet? What did I teach you yesterday about that common denominator? Just multiply the top and bottom by everything by y to get rid of that y. You don't want a fraction within a fraction. So the best and final answer is negative 2x y to the 3rd minus 2x to the fourth all over y to the what power? Fifth. That is the second derivative. That is d squared y over dx squared. I know. Could you imagine taking a third? That is hard. But I lost you, where did I lose you at? I don't want to lose you. The start. You're taking a derivative of a derivative. I'm saying, hey, Liam, take the derivative of this. And you had to do quotient rule. So quotient rule says, yes, so maybe I should put QR, quotient rule. And then I did denominator, derivative of the numerator, minus numerator times derivative of the denominator. And if I take a derivative of y, I attach dy dx. I mean, if you had gotten this far, I'd probably give you like just good old half credit or something, just cleaning it up. Little by little, I would give you more and more and more credit. So FYI, and you won't have too many of these. All right, let me do 311, and that will be it. I gotta look to see what 311, because I wrote do 311 together. And I'm like, okay, sure, I'll do 311 with you. I think it's asking for, oh yeah. This is number 311 from your homework. You're welcome. X squared y squared plus 5xy equals 14. They've given you a point, and they want you to find the equation for the tangent line. Find the equation for the tangent line at the point 2, 1 of this equation. Boom. So yes, you're happy, no double derivatives. Woo. But you will have to do one of them, I believe. I'm just looking, I know it's one of them. And by the way, these are gonna look nasty. If they look nasty to you, you've probably done it right. Just so you know, you're gonna be like, okay, great. So do you see a bunch of X's and Y's next to each other? You know what that means? Product rule. Okay, so let's take this time piece by piece, piece by piece, piece by piece, piece by piece, and then we'll plug it in at the end and we'll be good. All right, so product rule. First times, what's the derivative of y squared? 2y, did we take a derivative? dy dx. Plus second, times the derivative of the first, which is just 2x, don't need to attach anything. Done, that was the first one. See, it's not hard. All right, you do this one. I would do 5x and y, like that. That would be my first, that would be my second. So you gotta do product rule here too. So first times. I should probably put that in front, but whatever. Did you get this?
Yeah.
I'm gonna rewrite it in a minute because yeah, and what does it equal? 0. Okay, now, I hate the way this looks. And I would say if you really want to take one, I know it seems a lot like, take a moment to clean this up. Here's what I mean. Put this in alphabetical order. So 2x squared y dy dx. Put this in alphabetical order. 2xy squared. 5x dy dx. That's fine. You can leave it like that. And then this y5, I should really have called it 5y. I know that seems annoying, but just that little bit right there will save you a headache, okay? Now, what's the next step that I have to do? How do I simplify? What do I have to move over? All right, first move the things over that don't have dy dx. So 2x squared y, dy dx, 5x stays with the dy dx. And the other side becomes a negative 2xy squared and a minus 5y. Then yes, I do factor this side. Do you remember doing this with logs last year?
Yes.
Okay, remember we had like log ln, and we'd have to do it. And that's when I usually can tell who's ready for this, because this is what this reminds me of. It's just with, oops, look at me, I'm talking. That's your dy dx right there. Would you all agree? Oof. Check and see if you did what I got. Now, you might think to yourself, oh, we're done. Not. Why aren't we done? We got to plug in. And so this is why implicit differentiation helps. I know, I'm sorry. But good news, look, it's a 2 and a 1.
Oh.
It's a 1. Okay, so So what you're doing is everywhere you see an X, you're going to put in a what? 2. And everywhere you see a Y, you're going to put in a 1. So really, this is -2 times 2, which is -4. This would be -5 times 1, which is -5. See, it's not that bad. It's not terrible. Because even when I just looked at this, I'm like, I don't want to do it. But then I'm like, it's not bad. 2 squared is 4. 4 times 2 is 8 times 1. So 8 on the bottom. And then 2 times 5 is +10. So what do I have? A -9 over 18? What's that slope? -1/2. There's your slope. There's your point. Can y'all write the equation for the tangent line now? Yep, y2 minus y1. Or y minus 1 equals -1/2.
Can I see a little bit more of it?
And it was, but does it? I don't know. It makes me feel like I'm so smart. Look at how brilliant I was. What is that? +1? +2?
I'm so tired. I'm mess up with myself.
Well, there you go. I did 311 for you, so you're welcome. All right. Anyway, I know that was good. You do not have to do this till tomorrow, though. Listen, really. Let me stop this.